Alright, here's how you can set up some of the questions from the textbook. They have the circus high wire act thing, and so they've drawn it down here at the bottom. So they basically have a wire that they could walk up, but they prefer to make it a bit longer, like this one, because it's a little easier on them. So they say this angle is 35 degrees. If that angle is 35, then I can also say what this angle is, because this is a straight line. So the whole thing's 180. So 180 minus this 35, what is that? 180 minus 35, 45. 145. So this angle here is 145 degrees. Let me draw a better triangle over here. So it sort of looks like this, where this angle is 145, and then they say they had to walk 30 feet away from the first one to this one, so that's 30 feet. And they also tell you that the wire is 122 feet long. And so I have a side, and the contained angle. So that's a law cosine question. So it would be the a squared is equal to b squared plus c squared minus 2bc cos a. So, and I'm looking for this side over here. So this is angle A, this is side A. And that's the one I'm looking for, because they want to know how much longer it has to be. So I'll find out this total distance. Maybe it's 130, I have no idea. But then they say how much farther will it be. So you would just subtract the original number from that one. Okay, so that's A, and then you can put your B's and C's in other spots. But the key thing is 122 here, 90 there, or 30 there, and this angle is 145. So knowing an angle, or the two sides, and a contained angle, use law cosines. Here's another one. I've got a baseball player. So I've got, here's the bases. And it rolls 34 feet at an angle of 25 degrees with the base path. So here's the base path here. And so the ball's rolling here and stops, or gets caught or grabbed. Anyway, this angle here is 25 degrees. And they want to know how far the pitcher's got to travel to pick up the ball. So here's the pitcher. He's going to have to run this distance. So that's going to be x. And then they say the pitcher's mound is 60.5 feet away from home plate. So that distance there is 60.5. Okay, so I have, oh, and what else did they say? Well, it rolls 34 feet, so this distance here is 34 feet. I got to draw a bigger triangle. So I've got here, the ball rolls, the pitcher comes to get it. Okay, and so this is my x. This distance is 60.5. This distance is 34. That's how far it rolls. But then this is a funny angle. So this one here is the actual base path. So they say this angle is 25. But that doesn't help me a whole lot, because this is the triangle I'm working with. And I have two sides. If I can figure out what that angle is, then I'm away. It's just like the last question. Well, they do give you a hint that the baseball diamond's a square. So if it's a square, each of these angles are 90 degrees. So this whole angle here is 90 degrees. Half of it, so this half would be 45, and this half would be 45. But if they've said that this is 25 to there, then the last little bit of that will be 20. So this angle here is 20 degrees. Let me show you that again. So I've got a square. I'm not very good at drawing those. Square. Here's the pitcher's mound. And so if I were to sort of draw four triangles there, each of them would be right angles. So this is a right angle. But this one here was a right angle too, but it gets cut right in half. So this angle is 45 degrees, and this angle would be 45 degrees too. And so if they say from this line here if it comes out 25 degrees from there, so that angle's 25 degrees, then to get 45, that angle there has got to be 45 minus the 25, or 20 degrees, like I said. So now I've got a side, and a contained angle, law of cosines. Okay, the last question. Two ships leave a harbor. First sails north, 15 degrees west. So the way you read those is that sort of here's a compass. Here's where they start. So they're going north. So this is north. North is this way, west and east. And so they're going north, but then 15 degrees off of that to the west. So this way. So this angle here is 15 degrees. Then they say another boat sails north 32 degrees east. So north, again, would be going straight up, but they want 32 east, or 32 to the right of that, over here. So this angle is 32 degrees. So when you're looking at it, and then they say how far apart they are after 2 hours. So here is one boat, and here's the other boat, and I want to know the distance between them. Let me draw another triangle right below. So here to here, this is where the boats are at, and this whole angle, part of it's 15 and part of it's 32, so altogether that angle is 47 degrees. Then they say they're going 25 knots an hour, and if they go for 2 hours, then the first guy's got to be 50 knots. 50 miles an hour, right? A knot is 1 nautical mile an hour. So this would be, if they're going 25 knots after 2, they'll have gone 50 miles. And then the other one is going at 20 knots, so that's 20 miles an hour, nautical miles an hour, so 20 miles an hour, but they do it for 2 hours, so that guy would be 40 away. So this is the exact same question as the other two that I had. Here are two sides, and there's a contained angle. I use the law of cosines to figure out that side. Same thing here. I have two sides. I have the contained angle. I'm figuring out that side there. Hopefully that helped.